A few questions coming in regarding question 8.44 from the homework. Choose the best Lewis structure from those presented below. So all of these are Lewis structures, but not all of them are correct. And to determine that, we want to check our rules, right? We want to check the formal charges. We want to check the octet rule just to see where we fall for each of these molecules. And so if I start with the epoxide on the left and I take a look, I've got two things going on here that I need to take a look at. The first, oxygen, right? Oxygen is group 6, and if I take a look, I want to assign the formal charge to help me figure out, is this the correct structure or not, or is this the best structure or not? So oxygen is group 6, and then we want to subtract all the assigned electrons to determine formal charge. So I've got 1, 2, 3, 4 electrons assigned, right? To determine assigned electrons, we count 1 electron for each bond and all electrons that are lone pairs. So based on that math, I should have a charge of 2+ on the oxygen. Take a look at carbon. Carbon is group 4, and I have 1, 2, 3, 4 electrons assigned to it. So that carbon is neutral. Take a look at the other carbon. The other carbon is also group 4, and I have 1, 2, 3, 4, 5, 6 electrons assigned to that carbon. So 6 electrons assigned, right, gives me a charge of -2. All right, the next one down, this dimethyl ether here. Take a look again. Carbon is group 4, and I want to have 4 electrons assigned. 1, 2, 3, 4. Perfect. Carbon is group 4, 1, 2, 3, 4. So both of those carbons are neutral. Take a look at the central oxygen. The central oxygen is group 6, so I want to have 6 electrons assigned. 1, 2, 1 electron from each bond, right? So 2 electrons there. 3, 4, 5, 6. So 6 minus 6, right? This molecule, as written, is perfect. I don't have any formal charges that I'm carrying. Each atom in the molecule also has a full octet of electrons. Choice C, take a look at the carbon again, right? Carbon is fine, 4 electrons, and it's group 4, so a neutral on that carbon. The central carbon, however, we run into some problems because the central carbon, again, it's group 4, and I've assigned 1, 2, 3, 4, 5, 6 electrons. So I should have a charge of -2 on that carbon. And get to the oxygen now. Again, oxygen is group 6. I want to have 6 electrons assigned. So 1, 2, 3, 4 electrons for each of those, 1 electron for each of those bonds for a total of 4. So 6 minus 4, right? A charge of 2+ on that oxygen. I get to this last structure here, another epoxy-like structure, epoxide-like structure. Take a look at the carbons. Both carbons are fine. 1, 2, 3, and 4. So 4 minus 4 is neutral. 1, 2, 3, and 4. 4 minus 4 is neutral for both of those carbons. So both the carbons are fine. We take a look at oxygen. Oxygen is group 6, and I have 1, 2, 3, 4, 5, 6 electrons assigned. So 6 minus 6. This oxygen is neutral, but now we need to check one more thing. How many electrons do I have in the octet of this electron? And to determine electrons in the outer shell, now we count all of the bonding electrons and all of the lone pair electrons. So this central oxygen has 1, 2 electrons here, 3, 4, 5, 6, 7, 8, 9, and 10. So that electron count for oxygen is a violation of the octet rule. Oxygen cannot have more than 8 electrons, so this is an invalid structure. These two structures I'm carrying greater charge than I would like, right? I want to have the structure that has the fewest elements carrying charge, and that is structure B. So structure B, everything is following the octet rule, and I have the fewest number of atoms carrying charge.